All right, here we are. It was a long week of notes, but we are on the final day. And actually, we only have like a page and a little bit to take notes on. Okay, let's go ahead and get our red pen or colored pencil or the crayon to do underlining of something that we write. New types of maps. Let's go over here. New, capital N-E-W. Types, capital T-Y-P-E-S. Maps, capital M-A-P-S. Notice I cut out the word of because we're taking notes and we don't need to write everything. Switch to a pencil. People have been making maps for thousands of years. Today, maps are more accurate than ever before, and they also show new types of information. So, new types of maps are more, M-O-R-E, accurate, A-C-C-U-R-A-T-E, and they have new information, new, N-E-W, info, I-N-F-O. For example, NASA, and that's the National Aeronautics Space Administration. So that's the U.S. government entity that basically does the shuttles going into space and a lot of different satellites and the space station, everything looking from space. Well, they take pictures from space too. They have developed maps using images from satellites. These images show land and water surfaces all over the world and can be updated as often as needed. Satellites are also used to observe large-scale weather systems, helping meteorologists make weather maps and forecasts. So they can take pictures from space. If something changes, like let's say a huge hurricane comes through and changes the shape of the coastline, all they have to do is tell it, send up some code and put a program in, take a new picture. Boom, done, updated. Whereas thousands of years ago, you'd have to sail up and down the coast in a boat over the course of weeks and months and draw a map by hand. So things are really fast and really easy now. And then they can take pictures from space of all that weather and see what's going on, and they can follow the path of a hurricane, and then they can make predictions about future ones based on what they know. Okay, let's see. Let's talk about satellites and how they can update often. Satellites, S-A-T-E-L-L-I-T-E-S, update, U-P-D-A-T-E, often, O-F-T-E-N, often. Scientists have been able to map the ocean floor by using sonar. Okay, sonar is like the noises and clicks that dolphins make. You send a sound wave out from one place, it bounces off and comes back, and then you can measure the amount of time it takes and figure out if something is really deep or really shallow. So if you send a signal and it goes beep and it just comes right back, you know that the floor of the ocean is right there. But if it goes for a really long time and then it takes a really long time for it to come back, you know that the ocean is very, very, very deep right there. In this technology, sound waves are sent down from a ship, then bounce up from the ocean floor below. A similar technique called LiDAR is used to map coral reefs. LiDAR stands for Light Detection and Ranging. It uses laser light instead of sound waves. LiDAR-made maps of reefs are accurate to within a few centimeters. So basically the size of your thumb. Okay, so let's talk about sonar. S-O-N-A-R equals reflecting R-E-F-L, E-C-T-I-N-G, sound, S-O-U-N-D. So sonar is reflecting sound. LiDAR, L-I-D-A-R, is basically reflecting R-E-F-L, E-C-T-I-N-G, light. You shine a little laser light down onto something, and then you have a special detector that can measure the amount of light that reflects or bounces off and comes back to you, and you can figure out what shape it is or how far away it is. The Global Positioning System, GPS, is a system of 27 satellites orbiting Earth. The GPS satellites continually send radio signals that can be picked up by anyone with the proper receiver. Okay, well this book is pretty old. By now, I'm guessing that 27 satellites is probably in the hundreds of satellites. I'm sure there are more satellites and it's more accurate than ever. And now even your cell phone can have GPS. Cell phones, tablets, the little map things that some people have in their cars. But that's pretty cool that a device that fits in your pocket can bounce a signal all the way up to these satellites in outer space and use that to figure out where you are. Airplanes are equipped with GPS receivers, as are many cars. So is your cell phone. By measuring the distance to at least 4 of the satellites, the receiver pinpoints location very accurately. I think now it's even down to 3. I think now they can figure out how to use 3 satellites only to pinpoint or triangulate. See, triangle, 3. Triangulate your position. So let's put capital G, capital P, capital S, arrow, satellite, S-A-T-E-L-L-I-T-E, positioning, P-O-S-I-T-I-O-N, position, I-N-G. So the GPS is basically satellite positioning. It uses satellites in outer space to tell you your position on the Earth. As technology continues to change and improve, so will the maps that people use to understand Earth. Maybe people will still get lost, but that shouldn't happen because of their maps. And basically, these days, you actually have like Google Earth, where it can take such good pictures you can zoom all the way down in and see buildings and see cars and see trees. That didn't exist when this book was written, so they didn't even know about that. Identify some types of maps made possible using modern technology. Okay, well, some types of maps that are possible using modern technology include maps made from sonar, which is reflecting sound, and that's especially useful in mapping the ocean floor. LiDAR, which is reflecting light, and a LiDAR-made map is good for really fine, detailed things like coral reefs. And then GPS maps tell you where your position is. You can use satellites to find your position, like Google Maps or MapQuest. I don't know if people still use those. Any of the maps on a phone or on the internet. Okay, visual summary. So remember, these things at the end where they say lesson wrap-up and visual summary, these are the super most important things they think we need to know. So let's make sure that we have these in our notes. Water covers most of Earth's surface. Let's go back and look at our notes and make sure we have that. Most Earth, 70% covered by ocean. Boom. Less than 30% of the surface is solid land. Okay, well, if most of the Earth is covered by ocean, then yes, less than 30% is land. Do we have that number, though? Let's go ahead and put that over here. Right here, less than 30% land, L-A-N-D. Features on land include mountains, hills, valleys, and bodies of water. Okay, where did we talk about features? Well, there's the heading land features. We talked about valleys, rivers, combination of the two river valleys, mountains, canyons, plateaus, and that most of the canyons and valleys are carved out by water. Okay, so we have that. Next one, topographic maps, picture Earth's features. Okay, let's go look at features. Let's look for topographic map. It shows the shape of a surface, and it also shows the features and the elevations. Okay. Contour lines show elevation. Yep, they connect points on the map that are at the same elevation. Contour lines bunched together show a steep landform. Okay, so if the contour lines are close together, it means it's very steep. And if they are far apart, it means it's pretty flat. And notice that they never cross each other. Geologic maps show surface rocks and other features. Geologic maps. Geologic maps. Geologic maps. Surface rocks and other features. Let's see, they show surface rocks and other features or landforms. Okay. Scientists use these maps to find resources. Okay. So those maps have resources on them and also things that are major hazards. New technology has provided other kinds of maps. Yep, there are many new kinds of maps and new technology such as Sonar, which is reflecting sound, LiDAR, which is reflecting light with a laser, and GPS, which is using satellites to help us find our position. All right, that is it for Lesson 3. We are done. Remember to go put these in your AVID e-binder. Good job persevering. Roar Wildcats!